Hello, Year 3. Welcome back to your maths videos. In today's lesson, our learning objective is, can I compare fractions and understand that the higher the number of equal parts, the smaller each part? Okay, the first activity is something for you to discuss. Pause the video. This is based on our previous lesson, our previous video on equivalent fractions, and the rule that we learnt about in terms of the number that we have to multiply the numerator and the denominator by to find its equivalent fraction. So have a go at doing this and play the video when you're ready. Okay, did you spot which one was different? Well, if you look really carefully, you will notice that if we look at all the denominators, all of them are in the same times table apart from one of them. Well, let me start with 3. Let me pretend like all of them, well, let me check to see whether all of them are in the 3 times table. Is 15 in the 3 times table? Yes, because 3 times 5 equals 15. So if I was to multiply this by 5, let me see if my numerators would work out as well. 1 times 5 is also equal to 5, so these are equal. Is 8 in the 3 times table? No, I know that 3 times 3 equals 9, but I don't have 8 in the 3 times table, so this can't be an equivalent fraction. 3 is 6 in my 3 times tables. So I know that 3 times 2 equals 6. So if I was to do 3 times 2, I would have to multiply my numerator by 2 as well. Let me see if it works out. 1 times 2 equals 2, which I have here. So this is also equal to 1/3. How about 30? Is that part of my 3 times tables? I know that 3 times 10 equals 30. So if I've multiplied this by 10, how about if I was to multiply the numerator by 10? 1 times 10 also equals 10, so this is also an equivalent fraction. How about 12? Well, I know that 3 times 4 is equal to 12, so it is in the 3 times table. So if I multiply this by 4, I would have to multiply 1 by 4 as well, and 1 times 4 equals 4, which I have here. So all these fractions are equivalent to 1/3 apart from 3/8, because 8 wasn't in the 3 times tables. Okay. William uses a fraction rule, which hopefully you use this fraction rule to complete your activity for the previous lesson, so you should be familiar with it. William uses a fraction rule to help him compare 1/6 with 1/4. Explain how he can do this. Use the fraction rule to compare 1/10. Oh, that's the one you do after, so don't worry about this yet. So can you help him compare 1/6 with 1/4? Pause the video and have a go at finding 1/6 and 1/4 and look at what you notice. Okay, so I have got 1/4 here and I have 1/6 here. What do you notice? Well, we can see that 1/4 is bigger than 1/6. But how come? I thought a bigger number would represent a bigger fraction. So why is it that when the denominator is smaller, the fraction is bigger? And if the denominator or the number of equal parts are larger, the fraction is smaller. Why do you think that is? Pause the video and have a think or talk to your partner. Well, my denominator represents the number of equal parts that the whole is divided into. So for example, if we have a cake and we cut it into 4 equal parts, and then we have the same cake, but this time is cut into 6 equal parts. If we only cut the cake into 4 equal parts, the slices are going to be bigger. But if we're going to cut the cake into 6 equal parts, because we're cutting it into a larger number of parts, each slice is going to be smaller. Okay, now, so how could we compare the two? So we have got 1/4 and 1/6. Which one of our bigger than, less than, or equal to sign should I put in between? Well, I know that 1/6 is smaller because the higher the denominator, the smaller the number of equal parts. So I know that 1/4 is bigger, and therefore I use this sign. 1/4 is bigger than or larger than 1/6. Now pause the video again. Use the fraction rule to compare 1/10 with 1/8. Okay, let's look at 1/10 and let's look at 1/8. Well, 10 I know is a bigger number, but it's my denominator, so it means my whole has been divided into 10 equal parts rather than 8 equal parts. If it's only divided into 8 equal parts, the parts are going to be larger than if it's divided into 10 equal parts. So let's compare 1/8 to 1/10. Pause the video. Can you put the correct sign in between these two to compare them? Oh. Okay, so I know that if my denominator is bigger, the number of equal parts are smaller. As we can see here, 1/10 is smaller than 1/8. So 1/8 is therefore larger than 1/10. This is your first activity to do by yourself. So pause the video and use this fraction rule to compare these unit fractions. Play the video when you're ready. Okay, now, so you've had a go at doing this by yourself now. Let's do a couple together. So 1/3 we are comparing to 1/6. Let's look at 1/3 and let's look at 1/6. So I can see that 1/3 is a lot bigger than 1/6. Why is that? Well, it's because in 1/6 the whole has been divided into a larger number, a bigger number of equal parts. Whereas in 1/3 is divided into a smaller number of equal parts. So 1/3 is bigger than 1/6. How about 1/12 and 1/5? Well, I know that for 1/12 the whole would have been divided into 12 equal parts. So each part is going to be quite small. 1/5, well, the whole is divided into 5 equal parts, so the parts are bigger. So 1/5 is larger than 1/12, or 1/12 is smaller than 1/5. So now that we've got our answers, how could we complete this sentence? Pause the video and have a go at completing it by yourself. Okay, so when the numerators of two fractions are the same, the smaller or larger the denominator, so let's go with smaller. When the numerators of the two fractions are the same, the smaller the denominator, the larger the fraction. Or the larger the denominator, the smaller the fraction. How could you use strips of paper to compare 3/4 with 1/4? Pause the video and have a go by using paper strips the way I've shown you before in previous videos to fold it. So you fold it in half. You fold it in half and then you fold it in half again to get quarters. Okay, so this is what it should look like. So here we've got 3/4, 1, 2, 3, and here we've got 1/4. We can clearly see that if we have 3/4, it's going to be larger than if we only have 1/4. So if the denominators are the same, the larger the numerator, the larger the fraction, because it represents the number of parts that we're considering. So the more parts that we consider, the larger it is. Okay, these are your independent activities for you to have a go at completing by yourself. Make sure you take pictures of your work to upload on Tapestry and share it with us on Facebook and Instagram if you would like to. See you in the next video, Year 3. Well done. Bye.